there's inherent soil properties, you know, like texture, location in the landscape, things that you really can't change. Those are inherent properties. Then there's dynamic properties. Those are the properties that we can change with management. And that's a lot of what we're going to talk about today and show. So this is just a demonstration. This is not scientific in nature. So I'm going to compare what we think is a well-managed soil. It's in the early stages of that management, I think since 2019. And then we're going to show a soil that maybe hasn't had as good management, and maybe some of the inherent properties are working against us. So those of you that have seen this before, what's supposed to happen when you compare a well-managed soil to a soil that's not as properly managed? What do you expect to see?
One to fall apart.
One to fall apart. Now, why would we expect that on a poorly managed soil?
Because it's been tilled and there are no soil aggregates left in it. Exactly. So it doesn't have any, like it doesn't have the spongy material to hold it together.
Right, exactly. Did everybody hear that? It doesn't have those biological glues that help hold it together. So we've got 4 main soil health principles that we try to follow. We've got keeping the soil covered year round with either residue or a living plant. We've got trying to optimize or minimize disturbance is one of our principles. We want to keep something living year round as well, and we want to increase biodiversity, and that can be with plants mainly, but that also can be incorporating livestock, like what Donna is doing here with her poultry and her small ruminants. So those are our 4 principles, and we'll talk more about those as we look at a couple of the other demonstrations here. But I'm going to get a PED here from the better managed soil, and a lot of soil organic material has been added to the top of the soil. So we'll put that in, and then at about the same time we've got a PED here, and I'm going to try to get on a similar size here. This is from a site that really hasn't had a lot of management, and again, it's got some inherent properties that are working against us. We didn't really have a highly disturbed soil here, which is a good thing. We're not supposed to have that. But what we would normally do would be go to a field and get a PED from maybe a heavily tilled field, and you all have seen those. I think I saw a couple coming in to the farm today. But that's going to be our PED on this side. So we expect this one to really fall apart, right? And we expect this one to hold together. Well, let's see if that's what happens. So we'll put these in at the same time. And let's see. Initially, what do you notice here? Is it doing what we thought it was going to do?
Yes.
What's this one doing?
It's melting. That's
right. It's melting, right? This one, we see some bubbles coming out. See some bubbles coming out of this one as well. But notice the color of the water. Much more turbidity on this side. A lot cleaner over here. So from a water quality standpoint, which one is preferred? This side, right? The better managed soil, exactly. Over time, this PED will just eventually just totally dissipate. But from a water quality standpoint, from a soil health standpoint, this is not what we want. We want better management, more of those biological glues that hold the soil together, better infiltration, more organic matter. This one, noticeably, what can you see from a color standpoint? Which one looks better to you? Or darker, I guess. Which one has more organic material?
I'm just saying something.
This one? I agree. That's it.
Is more dirtier than that.
This one is more dirty? Okay, I can go with that. All right, so this one has much better color, much more organic material, right? So we would expect this. Do you guys have a problem with soil erosion in this part of the state?
Oh yeah.
It's basically the first step, maybe step 0 of looking at improving the health of our soils is being able to hold it, right, where we want it. and it not end up in the creek or the bayou or the water body. So again, back to management here. With poor management, a lot of this material is going to leave us. And typically, what part of the soil profile is going to leave first?
The topsoil.
The top, which is generally the what?
The better soil.
The best. That's the best you got. So the best you got is leaving first. So with proper management here, that's going to hold together much better than this. Is anybody having any extreme weather lately? Dry or right? This year's been terrible. We raised corn and soybeans on part of our farm, and it yielded about 40 bushel. Year before last, it yielded 185.
Wow.
So we had 6 weeks of a D1 drought at home, and then we got rain.
A lot of it.
So we had one extreme to the other. This type of management, pursuing healthy soils, is going to help buffer against those weather extremes. I think we're going to see more and more of that. So this type of management is what you want to implement. And this type of management here, pursuing healthy soils, is size neutral. It's size neutral. It's land use non-specific. It doesn't matter if you're in town and have a 1/4 acre or if you have 10,000 acres. Doesn't matter. This management will help you. This one obviously needs some improvement. And these soils were taken just right across the farm from each other. They're going to be very similar in inherent properties. Just management is different. So I want to key in on that we can make changes. It just takes patience and time and effort to do that. But we definitely can make those changes with proper management. As far as down here, but you can all come by and look at this. This is from the plot where they've added quite a bit of organic material to the top. So this is what they would have started with, a pretty sandy parent material here. And you see a lot of redoxamorphic features, which is poorly drained, indication of poorly drained, where you have the reds and the grays. Okay, so really not a great soil to start with, but look at what's happening with the organic material and the lack of disturbance. And you may not can see it, but there's lots of little pores.
Oh yeah.
And you see the root hairs, see the roots hanging off there. So what we're doing here is, by having this organic material and not disturbing it, those roots are making their way down into this, challenging soil, exactly,
Yeah.
and making positive changes. And we just quickly measured there about 8 inches down so far, and we're in the 3rd year, Donna, of
Right.
3rd year. So just great changes occurring, and that soil organic material is really the driver to that. By adding that material, that really expedites the process. You could get to here without doing that, with utilizing cover crops and no-till management. It would just take longer.
Right.
So really, what Donna has done here, I think what a lot of you are doing, it just expedites the process. It makes it happen quicker. It gets it to a healthier state quicker. So exactly. And the key here is the living plant and their roots. That's what's going to make the changes. Yes,
What
ma'am?
type of soil would you call that? I mean, I know there's a lot of clay in it, but what is the actual?
Actually, very little clay.
It's
Is
a lot
it?
of
It's a lot
sand.
of
A lot of sand.
Lot of
Okay.
sand, yeah, and you can come fill it, but it's gritty.
Okay.
So this
That would be kind of more river still than there.
this you got me out of my element on the soil down here in Louisiana. I just know for sure this has a lot of sand. If it had a lot of clay in it,
It would be sticking
it would
together.
Make a ribbon.
Okay.
When you do it like that, you see that
Yeah.
falling apart. If it
Okay.
had clay, that ribbon would come on down. So this
Okay.
is a lot of sand, and you can hear it. Very, very gritty soil. So that presents challenges.
Yeah.
Water holding capacity,
Yeah.
natural fertility, organic matter.
Yeah.
All those things are working against you with this type of soil.
Oh, that's beautiful
that's
too.
That's the benefit of adding this organic material.
Yeah.
That allows you to buffer that inherent property that I mentioned, and really allows you to produce a lot more on this type of soil.